Welcome back programmers. In the previous video we saw the basic stuff of TensorFlow. In this video we are gonna talk about tensor with random values. Now if you know Numpy, so you know what is this. So you can skip this, but I suggest you to see this video because in Numpy something is changed when you use TensorFlow. Because in Numpy you have to use random.random.randit, but in here you can see we have to use random normal. So let's begin. Now before start, please subscribe my YouTube channel to learn more about coding and share this video to other programmer. Hit on the like and the bell button and never miss my features video. Comment me for the next video. And if you want to see first part of this video, so link is in the description. So let's begin. So in the previous video we saw constant, zeros, ones and fill. We saw line space. Now we are gonna talk about tensor with random values. So the first few function is, first one is random normal. In the previous video I talked a little bit about this function, but now let's just use this. So I just opened my Jupyter notebook, and sorry for the background noise because this is too hot in my room. Okay, now let's begin. So first we are gonna use random normal. Now if you are using this book, so in here you can see it's just used random normal directly. You can see in here tf.random normal, but when I execute this in here, first I'm gonna import numpy as np and import tensorflow as tf. Tf is my buddy name, remember. Okay, now let's talk about what if I use the random normal function directly. I can't use, because let's try x equal to tf dot random normal. There is no random normal function available in here, but random normal initializer is available. So how we are gonna use random normal function? And for that we are gonna use random tf.random.random. Simply we are gonna use tf.random.normal. So this is the same function in here. Okay, now let's just pass the argument. First one is shape, or you can say elements of array. So let's add a list 1, 2 and 3, and let's just print the, let's take 10 for now, and let's just first print the x. So you can see it create a random element of 10 highest value, because we just add a 10 in here. Let's add 1 to 10. So it start with 1, lower value is 1 and end in 10. Let's add 3 to 10. So you can see it create a 3 list. So this is the shape of array. Let's just add 3, 3, 3. So you can see 3 array with 3 element with 3 lists. So the second parameter is d type. You can see in here d type is float 32, but what if you want to change d type? So let's change the tf dot, let's use integer 16. So you can see, wait, oh, we got an error. Attempt to convert a value tf.integer 16 with unsupported type. So why this is unsupported? Because in Python tensor.python framework.data type to a tensor, so tensor data type is unsupported in here. Now why this is unsupported? Because in here if random element is generated, so it has to be a float value. So how compiler are gonna change the float into integer. So that's why we have to use float in here. So let's say float 64, and even you can use the d type equal to in here too, d type equal to. So you can see the program is run successfully. You can see float 64, and let's change the 64 into 16. You can see the value is changed in here. So that's how you can create a array with random elements. Okay, the second one is truncated normal. So this is the same thing, but in here this create a tensor with normally distributed value excluding those lying outside two standard deviations. So basically truncated normal ensure that the tensor won't contain any improbably large or small values. So now let's just use x equal to tf dot random dot truncated normal. So let's pass the 3x3 array in here, and let's just print the x. So we are gonna talk more about in later video, but you just use all of these random function. So it means this create a normal random elements. Now random uniform create a tensor containing uniformly distributed value that lie between a minimum and maximum. Again, random uniform create a tensor containing uniformly distributed value that lie between a minimum and maximum. Because the distribution is uniform, every value is equally likely. So let's just use random uniform. So let's create x equal to tf dot random dot uniform, and let's just pass the 3x3 cube again, and let's just print the x. Now you can see whenever I run this code we can't see negative point, because for now this take 0 to 1. 0 is minimum and 1 is maximum. But what if we want to add minimum and maximum? So let's do it. So simply use min value equal to, let's say 5, and max value equal to, let's say 10. So you can see the minimum value is 5 and maximum value is 10. So 9.05684, it means this is 10. So whenever I run this, it creates a random value, but the rule is minimum value is 5 and maximum value is 10. Let's say, what if we add 8 to 9? So let's see. You can see all of the elements is 8, but all of the element is randomly. You can't see same element whenever I run this code. Okay, so that's how we can create a random value with the minimum and maximum value. If I create a maximum value 999, so you can see we got 5659617 randomly generated. Maximum value is 999. So now you got the point. Let's move on. Now the fourth one is shuffle, random shuffle. So now let's use x equal to random dot tf dot random dot shuffle. So you can see the description. Shuffles tensor along its first dimension. So random shuffle doesn't create a new tensor, but randomly shuffle the value in an exiting tensor. This shuffling is limited to the tensor first dimension. So let's change the variable name y, and in here we are gonna simply pass these tensor. So let's change the maximum value to simplify the things. You can see x equal to tf.random.uniform, and this is the elements. So in here just pass the x and let's print the y. So whenever I print the y, it create a newly tensor with the use of random.shuffle. So in here so basically shuffle take a pre-built tensor and create a random value. So let's try again. Let's create a tensor. So a equal to tf dot. Okay, now let's just use numpy because we got numpy 2. np dot array, and let's create a array 1 2 3. Let's just pass the a. You can see this create a random with a pre-built array or tensor or matrix, whatever you can say. So whenever I run this code, it create a random value. So let's just add another elements 5 6 7 8 9 10. So you can see it create a randomly generated value, and it take a pre-built matrix function, tensor, array, whatever you can say, list. Okay, let's try with double dimension. So in here I'm gonna create another list 1 2 3 and 4 5 6. So you can see 4 5 6 1 2 3 randomly generating. So that is how we can use shuffle. Now the last one is set random seed. See the seed value for all random number generation in the graph. So I'm gonna talk more about graph in later video, but let's just see what set random seed does. So let's create seed for s equal to tf dot random dot seed. Oh, this is set seed. You can see we got set seed. Okay, we ain't got, yeah, this is same, set seed is same. In here name is set random seed, but in here random dot set seed. Okay, so let's try. Oops, I passed the a. So let's first check the description. You can obtain and set a seed value by calling set random seed, which accept a floating point value and make the argument the seed for every operation in the current graph. So let's just use, because we are not gonna create a graph for now. So let's just pass the float value like 4.3. You can see it got none, but it create a graph, but we are not gonna see for now. So let's just skip this. Okay, now that we know how to create a randomly generated array, or you can say tensor, with the use of this function, now let's just move on and let's see transforming tensors. Okay, so I'm gonna create a markdown in here. Transforming tensors. Now this is the very important part. If you don't know numpy, in numpy transforming array and lot of stuff available. So in here we are gonna use transforming tensors. And again, this is very important, please focus. So the first function is cast. Change the tensor data type to the given data type. Let's use this a equal to integer 10. So whenever I print the type of a, you can see we got integer, but let's say x equal to tf dot cast. Let's pass the a. Okay, we got error. Yeah, the error is we required to add a one more parameter. The one more parameter is in which data type you want to change this a. So let's say I want to change a into tf dot float. 6460 is okay. So now let's print the x. You can see class TensorFlow. Okay, now let's just only print the x. You can see the data type is float and it create a tensor automatically. So that's how we can change any data type into any data type. Now let's change integer to float in here, and let's change this tf.float16 into integer 64, and let's create this value to float. Now let's print the x. You can see we got 10 only. We ain't got 999 because we changed the data type float into integer, so that's why it got only 10. So that's all of the cast. Okay, now reshape. This is very important. If you know Numpy, you don't want to see this because you already know what is this, so you can skip 5 or 10 seconds. Now how to use reshape in here in TensorFlow. So let's say I have a array equal to np.array. So the shape of np.array is, I just created a 3 list and 3 element in single list, and I'm gonna simply print the a. You can see this is the this is array, sorry. So let's just create array. Let's just create a single dimension array. So 1 2 3 4 5. So whenever I print this and whenever I print the a dot shape, so you can see we got a, sorry, shape is not callable, and let's print. You can see we just got 5 because this list contained 5 elements, so this is single dimensional array. So let's change this single dimensional array into, and let's just add the one more element to store perfectly. So let's just change this shape into double dimensional array with the 3 element. Okay, how we are gonna do this? So simply let's just use x equal to tf dot reshape. This is the function, and simply pass the first parameter is a. Obviously what we want to change a, and simply in here we are gonna pass the shape of array. So I want to create 2-dimensional array with single list, and in single list I want to add 3 element. So let's print the x2. So you can see it create a 2-dimensional array with single list, and in single list it contained 3 element. So that's how you can create a reshape. So when I print the x dot shape, you can see we got 2 1 and 3 dimensions, sorry, 2-dimensional array, 1 list per in dimension, and 3 element in one list. So that's how you can reshape any array into any. If you want to change the 1 dimension into 2, you can do it. If you want to do 3 dimension into 2 or 3 dimension into 1, you can do it. You can do anything in here. Just add a list and tensor name because we are using TensorFlow. Okay, that's all of reshape. So the third one is squeeze. So this only removes dimension of size 1. So again we need to create a tensor. So we are gonna just simply use a. Let's change the A into double dimension array 1 2 3 4 5 6. But when I run this and when I print this, you can see the whole output is changed because I changed the elements. Output is doesn't change, but shape of A is changed. Okay, now let's just use squeeze. So let's say S equal to tf dot squeeze. First obviously is A. We're gonna pass this A in here. So it remove dimension of size 1. So let's just pass the A for now and print the simply S. So you got it, what just happened? It remove one dimension. So you can see in here, you can see there's a 3 list in here, and you can see there's only 2 list. It just remove one dimension. So what if we just create only one dimension? Let's do this. Let's have a fun in here, and I'm gonna create just only one dimension. Okay, I'm gonna remove all of this stuff. Oh, let's run this code. So output is same because you can't remove one dimension from one dimension. Okay, so if I just change this into like this, so you can see we got a single dimension. The shape is single dimension, and even you can try this and NDIM. You can see single dimension. When I use in here NDIM, you can see, oh, this is 0 dimension. Okay, I just print in another line. Okay, let's just print A dot NDIM. You can see this got 2 but this got 1 because we used squeeze. Squeeze remove one dimension. Okay, now that you know what is squeeze, let's move on. Okay, the fourth one is reverse. Obviously you know what this function does. Let's just use this. Reverse given dimension of the tensor. So we are gonna use A. Let's use R equal to tf dot reverse, and obviously we are gonna pass the A, and then we are gonna simply print the R. Okay, reverse missing one required positional argument, axis, whatever you say. Now what is axis? So I'm gonna talk later, but first let's pass the list 1. So you can see the whole list is reversed 3 to 1. But what if we pass another list 4 5 6? You can see the whole list is reversed 4 5 6 1 2 3. The reverse 3 to 1 6 5 4. So that's how you can reverse the array, or you can say tensor, with the use of reverse function. If I passed 2 in here, okay, so obviously it is gonna give me error. Now the error is axis 0 equal to 2 is out of valid range 0 to 1. So we have to pass either 0 or either 1. Now when we create a 1, the output is 3 to 1 6 5 4. When we use 0, the output is 4 5 6 1 2 3. Now you know what is the change now. So either you want to use 0 or 1. So if we use 0, so the output is it reverse whole full list, not element, only list. You can see the element is 4 5 6, but let's try this 7 8 9. So it first, okay, let's run this. First we got 7 8 9 reverse 4 5 6 and 1 2 3. but element is same. But if we use 1, so see the magic. 3 to 1, 4 5 6 7 8 9 8 7 6 5 4 3 2 1. So you can see the elements is reversed but list is same. So now that you know what reverse function does, so now let's talk about slice. So slice description is extract a portion of tensor. So we all know what slice does, so let's implement this. So again I'm gonna create a variable x equal to, obviously I'm gonna use a again, so I'm gonna use tf dot slice, and in the slice function I'm gonna pass the parameter a, and I'm gonna print the a, but I think I'm gonna get error because you can see slice function take two required positional arguments, begin and size. So let's add a 2 parameter. So from where I want to begin, I want to begin with, let's say 4, and the size I want to add is, let's say 6. Okay, I have to add a list format because expected begin and size argument to 1D tensor of size 1 dimension tensor of size 2, but got shape null and null, empty list and empty list instead. So let's change the a value to understand perfectly. So I'm gonna change a equal to np.array. Let's create a in here, so we can see a equal to np.array, and I'm gonna pass the list. So this is my list. So let's first print the a. So you can see a is a 3-dimensional array with 2 list and 3 elements. So now that we got a, now let's slice this a. So I want to slice this a like this, and when I print x, you can see the slice is complete and shape is still 3-dimensional array with 3 element, 1 list and 1 dimension. Sorry, 3 dimension with 1 main list and 3 element in 1 list. So where did this come from? So you can see in here, this is the begin value and this is the size. So you can see the size is shape. Now let's change the value. So you can see we got 444. If I change this to, so we got error, expected size 2 in list of 0 and 2 but got 3. So this is out of range, like, so we have to add in 0, and in here if we change 1 to 0, you can see we got 2 to 2. If we add all of the 0, so you can see we got 1 1 1. So now that you know the point, if we add 0, so we got 1 1 1 first lists. If we change into 1, so I'm gonna open paint to show you better. So let's say this is our array. So this is our array. Now in here you can see first one is represent this list. If we change in here to 0, so you can see we got 1 1 1 this. If we change in here to 1, you know index start from 0, so we got 3 3 3. If we change in here to 2, so we got 5 5 5. Let's run. You can see we got 5 5 5. So these 3 represent to this. Okay, now obviously you know what this and this represent. Let's try. If I change this 0 into, let's say 1, so you can see we got let's try this 0. So you can see we got 2 2 2, but which 2 2 2? This 0 2 2 2, because in here let's say this is 0, this is 1 and this is 2. So if we change in here to like 2, let's try. So you can see we got error because list index is out of the range. So let's try 0. You can see we got 1 1 1 because obviously this is 0. Let's change to 1. So we got 2 2 2, and if we try to add 2, so obviously we are gonna get error. Let's try 0. Okay, now you know what this does. So if 1, so 3 3 3. If I change this into 2, so we got 5 5 5. But if I change this into 3, so you can see we got error because list index is out of range. There is nothing in here. So let's change it into 2. Now 2, it means 5 5 5. But if I change in here 1, so you can see we got 6 6 6 because it represent this list 5 5 5. Okay, now let's change in here to 1. List index is out of range obviously. Now what is this? Let's change this to 0. So we can see if I change this into 2, obviously we are gonna get error because there is nothing more than 666. So either we can do 0 or 1. 0 is 555 and 1 is obviously 666. So basic, this is the beginning. Now let's change this. Let's see what is this. I'm gonna change all of this 0 and I'm gonna change this into 1. Now we got an error. List index is out of range. You can see expected size 2 in 0 to 2, but got 3. So let's try 0 1 and then 1. Still there is nothing more than 666 because we got only 6 list available. So that's why it has to be a 0. Okay, now that you got the point, let's move on. Now the sixth one is stack. Combine a list of tensor into a tensor of greater rank. So obviously this take a tensor as parameter, and let's just use this x equal to tf dot stack, and in here I'm gonna just pass the a, and I'm gonna simply just print the x. You can see we got 1 1 1 2 2 2 3 3 3 4 4 4 5 5 5 and 6 6 6. So basically it combines a list of tensor into a tensor of greater rank. So if we change the a like this, create a, let's change first and then I'm gonna show you. Let's say this is like 7 7 and 7, and when I run this code you can see this is same. But what if I create an list and pass the a and a and a, then you can see it create whole new array obviously. But when the pair operation execute, so the pack of the list of the tensor in value into a tensor with rank 1 higher than each tensor in values by packing them along the axis dimension. Given a list of length n of tensor of shape ABC, we just passed a, but the output is same but with n a. But if the axis equal to 1, then the output is a n b c. So let's change the axis 1. Output is same 7 7. You can see the all of the higher value is upper 7 7 2 2, again 7 7 2 2, again 7722. Let's just use a, so it won't be a difficult. Expected a sequence for attribute n got an end array with rank 3 instant, so it means it gives us a rank 3 instant, so that's why it got me a error. So let's try to add a list in here a. So if we add a 3a in here to compare, so you can see first we got higher, then lower, then lower. Now you are thinking why 5 and 6 is here, so because of the x is equal to 1. Now you can search more about in Google about this tag, you can go in the official site too, but now let's move on. So Unstack, split a tensor into a list of tensor of lesser rank. So basically I'm gonna just copy this and paste in here, and I'm gonna use lower stack. Sorry, Unstack. And when I run this code, you can see first we got 722, 722, and then 34, 34, 34, and 56, 56, 56 because of x is equal to 1. So that's how you can use stack and unstack. More information is available in Google, you can check it out. Link is in the description of official TensorFlow. Okay, now that we used all of the transforming tensor functions, now let's creating a operation. So this is the next part of our syllabus, creating operation. Now I know you all use all of these functions, subtraction, add, multiplication, division, add, and so on, so but let's just use like one time. Okay, and I'm gonna create a markdown operations. Okay, now let's create a constant. Let's say a equal to tf dot constant. You can use variable or numpy, whatever you want to use, but I'm gonna use constant to show you. Let's say constant is 5 and b equal to tf dot constant, and this is 5 2. So let's print the a and b. You can see tensor 5 shape 1 data type equal to integer 32, tensor 5 shape 1 data type equal to integer 32. Okay, now let's create an operation. So the first one is add, obviously. So let's use add equal to tf dot add and pass the a and b. Let's print the add. So you can see you got 10, 5 plus 5 equal to 10. So this is the basic stuff, you all know what is this, and that's how you can change add to, let's say I'm gonna copy this and paste this subtract. So let's use subtract, in the subtract I'm gonna use subtract function, and I'm gonna use sub variable. So you can see we got 0, 5 minus 5 is 0. Let's change the value 10. Minus 5 we got minus 5, and in here we got 15. Okay, so that's how we can use add, subtract, multiplication, division, div. Only div used for divide the element, and divide is used for divides element. So remember, div and divide is kind of same. Now add n is used to add a multiple tensor. So I'm gonna copy this, create C, equal to tf dot constant, and I'm gonna change the value like 7. So let's, no, 5 is okay for now. So let's add a multiple value, m equal to tf dot add n, and I'm gonna pass the multiple value a, b, c. Let's print the m. Okay, add and take from 1 to 2 positional argument, but 3 were given. What the hell? Okay, we want to add a input in here. So let's say we are gonna pass the 3 element but in the list. So we have to pass this element in the list. So you can see we got 20. So because if we want to pass the multiple value, we have to use list. Let's say a, b and c. So you can see we got 40. Now you calculate all of this stuff. A equal to 5 plus 10 plus 5 plus 5 plus 10 plus 5 equal to, you can see we got the output. Let's add another 2. You can see we got 45 because I just add a again. So that's the beauty of the add n. We can add a multiple value. So now let's just use. Now if you wanna use these, you can see t equal to a plus b. You can do it too. Let's just print the d. You can see we got 15. I'm gonna remove this print so we can see the output. Okay, we got another print in here. Okay, now that we got 15, so let's use minus b, and even you can use multiplication. Sorry, y multiplication b. You can use division, and even you can use double division like this. You can see we got 0. And if you want to use module, this is the module, so we can do it. Okay, now let's remove this. What's the next function? Scalar multiplication. Scales a tensor by scalar value. Now I'm gonna suggest you to implement all of these functions so you can understand better. Okay, now let's use scalar multiplication, or you can say scalar mul, scalar and x we have to pass. So let's say s equal to tf dot scalar mul. So basically this function return scalar multiplication x of the same type, tensor or indexed slice as x. So we are gonna pass a, but in here we have to pass the scalar. Why this is disappearing? So in here we have to pass the scalar, or you can say shape. So let's pass the 1. So when I print the s, okay, I got an error because I add another. So we have to pass 1 and a. So you can see we got 5 because I just passed the a. So it changed the scalar and return scalar multiply a. So if I add a different shape like this, you can see we got error because array is a single element. So that's what scalar does. So now let's move on to mod. You know what mod does? This is perform module like this. I'm gonna give you a short practice for a module 2. So you can use module function 2. and when I print the C, you can see we got a 5. So that's what mod does. So now let's move on to the abs. So it gives us an absolute value. For example, d equal to 10.76. So let's use for absolute, let's just use v equal to tf dot abs and pass the d and print the v. You can see we got 10.76, but when I change this value into minus, you can see we still got 10.76 because it gives us a absolute value. You know about absolute value. Okay, negative negates the tensor elements. Let's use n equal to tf dot negates, sorry, not this, neg negative. Let's pass the a and print the n. You can see we got -5, and you know what it does, it changes the positive value into negative. Let's try different. So let's try -15. What it does, oh, it changed positive to negative and negative to positive. That's interesting. Let's pass the 0. We got 0. Let's pass the -0. Still got 0. So that's what negative does. Let's try 65 -65. So that's how you can use negative. Then the second last function is sign. Extract the signs of the tensor elements. Let's use s equal to tf dot sign and let's pass the a. Simply print the a. First I'm gonna remove this. Extract the sign of the tensor element. You can see the sign is nothing in here because we passed the a. Let's print s. You can see we got a 1. So if I change this value, still got 1. Let's try this now. You can see we got an error in add. So I'm gonna first remove all of this stuff. You can see we got 1 1. So basically it gives us a sign. So if I change like this, you can see we got 1 1 1. Yes. Okay, the last function is reciprocal. By its names, you can compute the reciprocals. So let's try r equal to tf dot reciprocals. So not this, reci. Okay, so this TensorFlow is not support the reciprocal. I don't know why. So let's try this. I'm gonna copy this and try this, but when I run this, you can see we got error. Module TensorFlow has no attribute reciprocal. So if you want to find the reciprocal, so you have to use tf.math.reciprocal. Now you can pass the a and then you can print the r. You can see we got error because could not find a weld device for node. Again this error, this shitty error. I don't know why I got this error again and again. I'm gonna solve it later, but you can use numpy.math.reciprocal. Basically this calculate the reciprocal. You can see the official documentation in TensorFlow. X and name, it basically take a one argument x, so it gives us a y equal to 1 divide x. So that is it, how you can use all of these function. So basic math operation is complete. So that is it for today's guys. In the next video we are gonna see rounding and comparisons and exponents and logarithm, vector and matrix operations and other stuff. So that is it for today's guys. If you like this huge video, so hit on the huge subscribe button, hit on the huge like button, hit on the huge bell icon, share this video to other coders like you. So that is it for today. Thank you. See you guys in the next video.